So let's put those inverse functions to practice. Cosecant. Cosecant was the inverse of, or the reciprocal. Cosecant is the reciprocal of sine. So one way to solve this problem with cosecant, cosecant is good. Cosecant is found in quadrants 1 and 4, just like sine is found in quadrants 1 and 4. So we don't need to do anything really strange here. But I want you to recognize that the way I can solve that is I can rewrite the problem as inverse sine of the reciprocal. So inverse sine of 1/2. Well, where is the sine value equal to 1/2? The inverse sine of the sine value is 1/2 when theta is pi over 6. So the inverse cosecant of 2 is at pi over 6. Or if we were in degrees, that would be 30 degrees. We found that by simply knowing our sine values, because if the cosecant inverse of 2 is the problem, then the sine inverse of 1/2 is how we're going to solve it. So let's move on to this next problem. Secant inverse of 3. Well, secant is the reciprocal of cosine. So I'm going to do the inverse cosine of 1/3. Now that's not on the unit circle, so I'm actually going to pick up my graphing calculator, and if I'm in degrees, inverse cosine of 1/3 will give me a value of 70.5 degrees. But this problem said to express it in radians. So make sure that you look at the instructions. I probably should have done that myself. Look at the instructions and make sure you know what they're asking for before you begin. So the inverse cosine of 1/3 in radians is 1.23 radians. Both of those values are in quadrant 1, which is where cosine would be positive and secant would be positive. Looking at the next problem, we have cosecant. Cosecant is the reciprocal of sine, so I'm going to do the inverse sine of negative 1/4. That's going to end up in quadrant 4. And it's going to end up in quadrant 4 because sine is negative in quadrant 4 and restricted, inverse sine, is restricted to quadrants 1 and 4. So in radians, let's type the inverse sine of negative 1/4, and we are going to get negative 0.25 radians. And remember, negative radians up until negative 1.57, which this is smaller than that, up to negative 1.57 is in quadrant 4. Now, when the cotangent value is positive, it's in quadrant 1. And that means we can use anything we want. I'm going to go ahead and use inverse tangent of 2. That's the reciprocal function and the reciprocal value. So the inverse tangent of 2, I'm going to type in the inverse tangent of 2. And that actually comes out to 1.11 radians. And that's in quadrant 1. That works fine. That's not a problem. This problem, D, that is going to be our concern because cotangent is negative in quadrants 2. Cotangent is restricted to quadrants 1 and 2, and it's negative in quadrant 2. But if I do the inverse tangent, that's in quadrant 4 because tangent is 1 and 4. So if I do inverse tangent for this problem, I have to do some manipulating to make it work. So I'm going to show you 2 methods to solve this problem. 2 methods to solve this problem right here. That's for problem D. Method 1, we go ahead and do inverse tangent of negative 1/2. You type that into the calculator and you do the inverse tangent of negative 1/2. And you're going to get negative 0.46 radians. That's in quadrant 4. My answer has to be in quadrant 2. So how do I get from quadrant 4 to quadrant 2? Using reference angles. If this is negative 0.46, then subtract 4.6 from pi. Pi minus 0.46 is, sorry, I did times on my calculator. 0.46 is 2.68 radians. And 2.68 radians is more than 1.57 radians, but less than 3.14 radians, so that's in quadrant 2. It was in the wrong quadrant, so we used reference angles to find our missing angle. Now, method 2 is recognizing that this is in quadrant 2 to begin with. So I'm just going to draw my triangle in quadrant 2. And I know that cotangent is x over y. That's going to be negative 2 over 1. And to find the inverse cotangent, I don't have that button for quadrant 2. I'm going to find something that is found in quadrant 2, cosine. Using x squared plus y squared, I find this is the square root of 5. And the cosine of theta is equal to negative 2 over root 5. So the inverse cosine of negative 2 over root 5, and we don't need to worry about rationalizing because the calculator doesn't care, we would type in the inverse cosine of negative 2 divided by root 5. And that's going to give us 2.68. Same answer, 2.68 radians, same answer, 2 different methods. That's the lesson for today. Good luck on your homework.